Okay, guys, we are going to go over Chapter 13 one more time. I think I've got it going now. I hope so, anyways, after trying so much. But anyway, so we're going to go over Chapter 13 one more time. I think this will help. And I'm going to show you a couple different things. I'll go over allegation again, in case you didn't get that. But if you guys, I'm actually just going to work through the post-test. But I'm going to go through the even ones, so you still have some to get through. I haven't worked through all of this yet, but I can get there. So we're just going to work through these, and I'm going to kind of go over some steps that you guys can take to get there. And actually, let me find I have some notes in here, so I wrote out kind of some steps you can take to get there. But let me just go over this with you guys, and then we'll kind of go from there. So let's look at number 2 on page 547. I'm just going to go through and explain how to do these. I'm not going to go back to that other section. Just get through these. Okay, it says if 15 milligrams, 15 milligrams of amoxicillin are added to 100 milliliters of sterile water, what's the percentage strength of the total volume of the prepared? Now this is easy. We know percents are always going to go over 100. So we're going to use ratios. So we have 15 milligrams. 15 milligrams over 100 milliliters. Now, here's the only problem. Whenever we have percentage concentrations, remember that this has to be in grams. It's grams per 100 milliliters. Grams per 100 milliliters. So don't forget that, okay? So we're going to have to transfer these 15 milligrams into grams. So it's going to go 0.015 grams is what we have. And we just want to know a percentage, so it's going to be X over 100%. Okay, so basically, that's what you're going to get. It says round to the 1,000. So 15 milligrams is added to 100 milliliters of sterile water. Percentage strength of the total volume of what's prepared. It's going to be 0.015%. So we'll get there. It's not that much. Okay. So let's keep going. So number 4. Okay. Let's go ahead and work out number 1 on that one too. I know this is the only one that you'll have. Let's work out number 1 on 547. Because that one's kind of like the opposite of what we just did. Okay, so look, it says how many grams of dextrose must be dissolved in sterile water to prepare 100 milliliters of a 60% solution. Okay, this one's going to be pretty simple too. Okay, set up your ratio. We know 60%. That's 60 grams in every 100 milliliters. That's what that 60% is 60 over 100. And we want to know how many grams of dextrose have to be dissolved in 100 milliliters of sterile water. Well, it's still going to be 60 grams because it's 60%. Okay. I made both of those a little too easy. It's like you don't even know if you're doing it right. It's so easy. Okay, let's look at number 4 now. A different marker. Number 4, we'll kind of get into these, and then hopefully you guys can apply some of these rules as you go. Okay, now this says a lotion of 5% methyl salicylate is to be prepared for a patient with allergic dermatitis. What amount of a 10% lotion would be necessary to prepare 8 ounces? Okay, so what we have to do first, so this is step 1, and you guys can write this on your formula chart. If you're trying to prepare a lower percentage, if you're diluting a medication from the stock thing, first thing you need to do is you need to figure out how many grams of the ingredient are needed for your order, of the active ingredient are needed for your order. So here's how we're going to do that. So that's step 1. We need to know the number of grams needed for the order. Okay? So we want to know active ingredient. Now remember, what we've got, okay, we need it for the order. So our percentage for the order that we want the 5% lotion. Okay? We want a 5% lotion. Now, what that 5% tells us is that it's going to have 5 grams in every 100 milliliters, or it might be 100 grams of medication, or whatever our measurement is. This one is a lotion, okay? Now, so that's what we want our final concentration to be. We want 5 grams in every 100 milliliters, because that's our percent. That's going to give us our 5%. Now, over here, we need to know, how do we get to, well, we've got 8 ounces. Okay, so we've got 8 ounces. We're going to say this one is, it doesn't say fluid ounces, so we're going to go with fluid ounces. So I'm going to say lotion is measured that way. So we've got over here, we know that we want our end volume to be 8 ounces. But we need to figure that out in milliliters, because if we've got grams and milliliters here, we've got to have grams and milliliters here. So our total amount, how much do we want in the end? 8 ounces is how many milliliters? It should be 240. 8 ounces is a cup, and a cup has 240 milliliters, and each ounce has 30 milliliters. So, okay, so we know in the end that's what we want. So we're trying to solve for X here. Okay, so if I work this out, I did not get my calculator here. So if we work this out, okay, 240 times 5 divided by 100, so we get 12. And what that means is that in order for us to get 8 ounces of a 5% lotion, we've got to have 12 grams, okay, of the methyl salicylate. So that's step 1, okay? So the grams we need for our order is step 1. Step 2, then we're going to figure out how many milliliters of the stock solution are required to get that 12 grams. So that's number 2. How much of the stock med do we need to get the grams necessary, or the whatever it is, to get the we'll say grams necessary. Okay, so now what we're going to do, we're going to do another ratio proportion method, but this time we're going to use our stock. So we know our stock is a 10% solution, so we know that there's 10 grams in every 100 milliliters, but we need 12 grams. We need 12 grams. Okay, so if I want 12 grams, I need to know how much of this do we need to get 12 grams of our active ingredient. So, oh, hello. Well, that doesn't really work in this situation, does it? Let me just do this. I'm going to get myself messed up here, and I'll mess y'all up. Should be 120, yeah. So 120 milliliters, I guess I should have figured that out in my head, is how much of our stock medication we need in our total volume in order to get the amount of active ingredient that we need. So we need 120 milliliters of the 10% solution, okay, to get to 8 ounces. So what we're going to do, now it doesn't ask this, that's enough for this question. But just so that you know how much, where you can go from here, Okay, the third step would be to get the amount of solvent necessary. So to get your base, remember your base doesn't have any medicine in it. Okay, so let's say we're mixing it with this like water, just plain water base paste or whatever to make it that lotiony feel, or aloe, or I don't know, whatever else you might put in. Okay, so if we have 120 milliliters, we know in the end we want 8 ounces, which is 240 milliliters, is how much medicine they should end up with in the end. Well, now we know that 120 milliliters of that 240 has to be the 10% solution. So what that means is of our total amount, which is 240, that's how much we want in the end, minus the 120 milliliters, which is the amount of stock medication that's in there. Now we've got, what, 120? Oh yeah, hello, 120 milliliters. Well, this, I guess we could have figured this one out. But anyways, 120 milliliters of our base, our base, whatever we're mixing it, whatever we're diluting it with. If I'm using water, I'm going to dilute this together. Okay? So that's how that is going to work. So that's those 3 steps. That third step was to get the amount of solvent. You just take your total amount, your order, your amount of medication that you need for your order, minus the amount of your stock medicine that you need, and that will tell you how much of your solvent that you need, the medicine that you're going to dilute it with. Now, I know you guys, we talked about alligation, but let me show you how alligation will also work with this, to do this. So if you want to use alligation to do this, you can. So here's what I'm gonna show you and why that works. Okay. So if I use alligation, like I told you guys the other day, you put your tic-tac-toe in the middle. Remember, you put the percent that you want. So I want 5% of a solution. My stock has 10%. Okay. Now, what I told you guys the other day was you use alligation whenever you've got 2 stock medications that are, like if you're wanting to get a 10% medication, but you've only got 5% and 15% on hand, then you can use this. But you can also use this if you're just diluting it. Because down here, if we put our base medicine down here, whatever our base is that we're mixing it, whatever the diluent is, it's going to have 0. It's going to be 0 amount. It's going to have 0% of the active ingredient. So then I can do the same thing. 10 minus 5 is 5. 5 minus 0 is 5. Okay, and that means we've got, and whenever you add these up, you've got 10 parts to the whole. Okay, so that means that of my 10% solution, I want 5 out of the 10 parts. And of my 0% solution, which here is the base, the diluent, I also want 5% of the parts. So that means that gives us kind of a ratio. It's actually a 1-to-1. We already learned that. But this will get us there. So then you can go back. Okay, I know in the end I want 8 ounces. I want 240 milliliters. Then you just do 5 out of 10 equals X over 240. Because that's how much your total amount is. That's how many parts, that's how many milliliters you have. So that's how many parts you have. So you're going to get, it's going to be 120. And you're going to get 120 of each. So alligation, if alligation makes more sense to you, instead of doing all these steps, you are welcome to use that. Okay? You are welcome to use that. So you can work that out either way. Let's work out a couple more so that hopefully, I hope that now I have maybe, I know it took me a while. I was telling my students here, for those of you guys that are in my online classes, I got so hung up on this chapter. It's like I hit a mind block or something, mental block. So I went to a friend of mine's house yesterday she's a pharmacist in Paris, and I went over there to get her to help me with this, and when I got there, I worked out every problem without she didn't even do anything. So I'm anyway, so I think I've got it going now. Okay, let's do number 6. All right, so a stock pint of sodium bicarb contains 60% solution. So that's our stock. Okay, stock is 60%. the physician prescribes 1.5 liters, 1.5 liters of a 15% solution. Now, what volume of stock would be necessary and what volume of solvent? So we're going to go through all three steps that we did a while ago. Okay, so I'm going to work it out both ways again. So first of all, we need to know how many grams of our active ingredient do we really need for this medication to work. Okay, so let's go, we got to go to our order first. So we're going to use our order in that step one. So 15%. We know goes over 100. That means there's 15 grams in 100 milliliters. That's how percentages work. And we know we've got 1.5 liters, which we know is 1,500 milliliters. And we want to know X. We want to know how much of our active ingredient do we need to get to our 15, I'm sorry. Yes, right, to get to our 1,500 milliliters. So, same idea here, just like we did. I could have done that if I had to. Okay, so we get 225 grams is what we need total. Okay. Now, let's go from there. Okay, so now step two. How much of the stock med do we need to get to these grams that are necessary? Okay, so our stock med we know is 60%, which goes over 100 again, 60 grams over 100 milliliters equals now 225 grams, because we know that's how much we need, over X. Okay, so we want to know how much of the stock medication do we need. So this time we get 375. So we need 375 milliliters of our stock medication mixed with our solvent, our base, our diluent, or whatever you want to call it. So we know total we want 1,500 milliliters. So this is the answer to the first one. So what volume of our stock do we need? Now we can figure out our solvent. 1,500 milliliters minus 375 milliliters. And that gives us 1,125 milliliters of our diluent, our solvent. Okay, now let's work this out alligation-wise again. Okay, so alligation, tic-tac-toe. In the middle, we put the percentage that we want, which in this case is 15%. At the top left, we put what percentage we have. That's our stock. And our bigger one that goes at the top and our zero is going to go down here because our base that we're using, our solvent, has none of our active ingredient in it. We're just diluting it. So 60 minus 15 is 45. 15 minus 0 is 15. So total we get 60. So 15 parts out of 60, or 15 out of 60 parts is your, is how you get there. So 15 over 60 equals X over 1,500 milliliters. Whatever that is. $375. So we get the same answer. So 375 milliliters is what we need of our stock medication. Okay, and then down here, we'll just do just opposite. 45 over 60 equals X over 1,500. To check ourselves here. we get 1125 of our base medication. Okay, so you can use either one of those as you're going through here. You can use alligation if this makes more sense to you. Okay, remember, just don't forget that you can't just do 15 over 45. It is 15 to 45. And there's 15 parts of the stock compared to 45 parts of that, but there's 60 parts total. So don't forget to do that you have to add up those parts. Okay? So there's your two ways to do those. Now, let's do number 8. Let's do a ratio one. Okay? So a liquid stock is available in a 1:350 concentration. Okay? So you can, I would just make these into percent. Okay, so 1:350 concentration is, I'm going to put that in a percent. So 0.3% is what you get for that. And then you're asked to prepare, your order is for a 1 in 500. So it's a 0.2 is what you've been asked to do. So that's how I would go ahead and put those into percentages. I just think they're easier that way. Okay, so that's for me. You don't have to do that if you don't want to. So if I go here, grams needed for the order, I know that I need to use my stock one, or what I'm ordering for first is 0.2 grams in every 100 milliliters. I know I've got my percent over here. Is equal to, how much do we want total again? A pint. So a pint is 2 cups. 1 cup is 240 milliliters. So a pint would be, what, 480? So 480 milliliters. This is going to give us our activate, how much of our stock solution we're going to need. I'm sorry. So it's going to tell us how much of our active ingredient that we need. Step 1 here. 0.96 grams is what we need. Okay. So now we go on to step 2. So now we go on to step 2. Now how much of our stock med do we need to get to those grams? So we know if we had a 0.3% stock, so we figure that out with our ratios. 0.3 grams in every 100 milliliters is equal to 0.96 grams over X. So this is going to tell us how much we actually need. 320 milliliters. Okay, so that's how much of our stock is necessary. So we need 320 milliliters out of the 480. So then we're just going to subtract, okay, for part 3, for step 3, we're just going to subtract our total amount, 480, minus our stock, which is 320, and that, then we get, what, 160, okay, and that tells us that's how much we're going to dilute it. So that's what we're going to use of our solvent. Okay. So if I wanted to do this in alligation, I can do that again, okay? So I know in the middle I want 0.2%. Here I had 0.3, and down here I just had 0. And you can do the same thing there. Okay? So that's that. I would say put those ratios into percentages for sure. So same thing, see on number 10, they mixed it. So they want 250 milliliters of a 0.05%, and they give it to you in a ratio. So I just put that on into your percent there so that you can do that. This one just asks you how many vials. You have to go back and figure that out too. But that's that. I think that hopefully that gives you guys an idea of how to do that. Oh, let's go ahead and work out a true alligation problem that you can really use that for. Let's look at number 18. Number 18. Okay, so the order is for 2.5 liters of a 6% solution. And in stock, we have a 5% and an 8%. And that's all we have in stock. So let's do our alligation. Okay, so we've got 6 is what we want. Okay, and we've got 8 and we've got 5. So remember, you subtract 8 minus 6 is 2. That goes down here. 6 minus 5 is 1. So that means total parts, we're going to add these together, we have 3. So that means of our 8% solution, that 1 out of 3 equals X out of, we want 2.5 liters. I'm going to go ahead and put it into milliliters just to make it easier. So 2,500 milliliters. We're going to end up with 833 milliliters. So we're going to use 833 milliliters of our 8% solution. Now down here, this is 2 out of the 3 parts. And now, this one's got 1,666.7 milliliters. Okay, so when we add these up, 833 plus 1666, those should add up to be 2,500. Okay, and that's what we wanted. Okay, so that's really the reason that we've been using alligation. It's just because it's got that. You can, you got 2 different concentrations of stuff, and you can use those to mix and make one concentration. So that is that. I hope that really helps you guys. Make sure and don't forget that when things are in percentages, it's grams per 100 milliliters, okay, not milligrams. So make sure you're paying attention to that. Make sure that your ratios that you're using always have the same units. If you've got grams on this side, you've got to have grams on this side, and so forth. The questions, some of these questions ask for grams or milligrams. So make sure that you're really paying attention to that. Okay, so I hope that helps you guys. I hope that kind of gives you a better idea of how this works. I'm sorry, I don't know why I hit that middle block when I think this chapter always scares me. I don't know why. But anyways, I hope that helps you guys.